Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the extra practice questions of the last unit of grade 11 chemistry, which is unit D. And with that, we completed that unit today. So this was the last video for grade 11 chemistry. And so let's start with that, and we were doing the extra practice questions of that unit. So the first question is about the balanced chemical reaction, where we done the first topic about the chemical reaction, and we include the states of matter and the formation of the reactions below. So first one is the aluminium metal reacts with the fluorine gas. So aluminium is a metal, they mentioned that, so which means we have aluminium as a solid. So aluminium solid reacts with fluorine gas. Fluorine is in the 2 state, so F2, this is the gas. Then so this is the combination reaction, so both are combined with each other, so this will become AlF3, because this has a 3 positive charge then, and this has a 1 negative, so this is from this, and this has also a solid thing. Now you have to balance this thing, and so we have a 3, we have a 2 over there and 2 over there. So this is the reaction of the combination reaction, we can say. Next one, the lithium metal reacts with a solid phosphorus. Again, this is the kind of the combination reaction. So lithium, which is Li, which is in solid, this is metal, plus solid phosphorus, and phosphorus in the P4 state, which is in solid, which will become Li has the I think 1 charge, and this has the 3. So you can divide this, and you will get a Li3P, which is again solid. Now you have to balance this, so we have a 4 over there, so this will become 4, so we have a 12, so this will become 12. Done. So this is the lithium metal, again the combination reaction we have. Next we have a chlorine gas reacts with the sodium bromide in an aqueous solution. So this is kind of the now double displacement, because we have one aqueous solution and we have a chlorine also. No, this is single. No, single. This is single replacement. So we have Cl2, which is the gas, and we have this sodium bromide in aqueous solution, which is NaBr, which is in aqueous, which will doing the thing like a single replacement. NaCl we become an NaCl, and we left with the Br, and this is still just in the liquid state, and this has a Br2. We have to balance this first now. So this is 2 and this is 2 also. So this is balanced now. Done with that. Next one is that the reaction occurs when a zinc strip is placed in the aqueous solution of lead second nitrate. So this is again the single replacement. So we have a zinc solid which is act with the lead second nitrate, which is NO3 negative and Pb2 positive. So this will basically become PbNO3 and hold to the 2, which is again the aqueous thing. When we could do this and we get the zinc nitrate, because zinc has again a 2 positive charge, aqueous, and Pb left as this solid as a matter. So this is again the single replacement. So the reactions are very important. The double replacement reaction is important for the net ionic thing. So like this one, if you have a net ion, if we have to make the net ion equation, so double replacement always is done. So they will give you a question of double replacement in the net ionic, so they test you on the both the chemical reactions and the net ionic thing. So the question says, in a laboratory test of metal activity series, a student places a strip of lead metal into aqueous nitrate. So write the net ionic equation for the reaction that occurs. So we have to write the net ionic equation for the, if we have a lead metal and we have an aqueous silver nitrate. How can we do that? So we have to write the equation like this. So Pb solid plus we have a aqueous AgNO3 we have, and this is in aqueous state. We will come PbNO32. For this, you have to check the solubility chart, that which thing is aqueous, which thing is solid, because this is very important. And we're left with Ag solid. Now you have to balance this thing. So for balance this, we have a 2 over there, and we have a 2 over there. Yeah. So 2, and we have 1 2 over there. Now the things which are in aqueous, we have to deassociate this in the ions. So in the cation and anion. So Pb solid remains Pb solid. We have 2 Ag positive because this is aqueous, and we have a 2 NO3 negative aqueous. Now this is the gain thing. So it's Pb2 positive basically, which is in aqueous, then plus NO2 NO3 negative, and we have an aqueous thing, plus 2 Ag solid. Now we have to left out the now we have to cut out the specter ions, the ions which are in the reactants and the products both. So Pb solid we know, okay. So we have to cut something else. So this NO3 cuts out with the NO3, and there's nothing else as that is the specter ion. So for the net ionic, we have Pb solid plus 2 Ag positive aqueous, which will give you Pb2 plus aqueous plus 2 Ag solid, and this will become your net ionic equation. So there's only one suspected ion of this. So that's how the net ionic works. And yeah, you have to do practice in these type of questions. The reaction practice, you have to know that how to make the any type of reaction. We do a number of type of reactions. You can see that first lesson of this chapter, so you get to know that how can we do, how we can make the reactions. Done. So next question we have over there. So the question says the powdered zinc matter reacts voluntarily with the sulfur when heated to produce a zinc sulfide. Predict the mass of the sulfur required to react with the 25 gram of zinc. So this is from the stoichiometry questions. And what type of stoichiometry we use, we have to identify that thing. So first we have to make the reaction of this. So we have a zinc reacts with the zinc sulfide. So zinc is in solid, and we have a zinc sulfide to produce the, so no, it's react with sulfur and zinc sulfide is produced. Right? So sulfur is acid, which is the gas, and zinc sulfide is produced. So ZnH, which is solid again. We have to balance this is just 8, and this also at 8. Then we have the mass of the zinc, this thing 25 grams. We have to predict the mass of the sulfur. So we have to find the mass of this. So what's the molar mass of zinc? Molar mass for zinc, you can check on your product table, is 65.41 grams per mole. You're going to find the N from here. What's the N? It's 0.38220. So from here you can like start find out the N, and you can find out the N for the S8 now. So this is type of the gravimetry stoichiometry. So the molar mass for this is something sulfur for is 256.56 grams per mole approximately. Yeah, so we have to find the N. So for the N, you can do 0.38220 moles into coefficient required is 1 and divide by the 8. So when you do this, you get about 0.04777 repeated moles. Basically, we have to find the mass for the sulfur. So this is molar mass multiplied by the n number of moles, because n is equal to the mass upon molar mass. So when you multiply this thing with this thing, you will get about 12 grams into this. So this is where stoichiometry, and where we use the number of moles, coefficient required, coefficient given, like that thing. So that's how you can do the actually the all the thing works in the stoichiometry of the gravimetry. So let's move on to the next question, and the question says the what volume of oxygen at HTP is needed to completely burn 15 grams of methanol in a Freudian burner. So we involve that in the methanol. So there's a combustion thing, because we have to find the volume of oxygen, and there's a burner thing. So that means the methanol is burning, which is the combustion. So methanol, the formula for methanol is CH3OH, which is in liquid form. It reacts with O2 gas, will produce CO2 gas and H2O gas in water vapors. So you have to balance this now. So we have a 3 and 4H over there. So there's a 4H and we become an 8H. So this becomes 2. This becomes 3 and this is 2. Done. We have a mass for the methanol, which is 15 grams. So you can find the molar mass actually from here. So it's 32.05 grams per mole, and you can find the N from here, which is 0.46801 moles. Then we have to find the volume of O2. So we need many things in this. So this is HTP. So means we have a pressure equivalent. Pressure in HTP is 0.1325 kPa. And we also have a temperature, which is 273.15 Kelvin. You can actually find the N from here. So N for O2 you can find 0.46801 into required upon given. So required is 3 divided by 2. So when you solve this, you get 7.020028 moles of O2. So basically get the N from here too. So you know the ideal gas law is PV is equal to nRT. This is a gas geometry. So you can isolate the V from here. You get nRT upon P. Done. So what's the N? Well, N is 0.702028 moles. We have R of 8.314 kPa per liter, dot liters. Basically the dot liters, and this has to be divided by the moles per Kelvin. Then, and we have a temperature 273.15 Kelvin, and we have a pressure of 0.1.325 kPa. So kPa cancel, moles cancel, and Kelvin cancel. You get the volume in liters, which is about 15.7 liters. You want to set this, which is 16 liters. Done. So this is that geometry, and we involve the geometry in this too over there, because this all connected to each other. You have to know about all the things, and they combine that thing in one question too, like two things in one. So that's how this works, and we find the volume of about 16 liters of the oxygen. Let's move on to the next one. The question says, in a laboratory study, 50.0 milliliters of sulfuric acid reacts with the 24.4 milliliters of a 2.20 moles per liter ammonia solution to produce an ammonium sulfate solution. From this evidence, calculate the molar concentration of the sulfuric acid at this stage in the process. So we have to find the now concentration thing, which means we are in the solutions geometry now. First, we have to make the equation. So sulfuric acid reacts with the ammonia, which is H2SO4, which is aqueous. It reacts with NH3, which is gas, and we will give it with the NH42SO4 aqueous. They combine that thing. Then balance this reaction, and we need only 2 over there. Then we have a volume of H2SO4, which is about 50.0 milliliters, which is 0.5 liters of that. We have to find the concentration of this, but we don't have the N of this. So we can find the N from the other things. We also have the volume for the NH3, which is 24.4 milliliters, which is basically 0.0244 liters. We have a concentration of 2.20 moles per liter. We can find the N from here, which is C times V. So C times V, which is 2.20 times 0.0244, we get 0.05368 moles. Now you can use the derivative geometry to find the N for the H2SO4. So N for H2SO4 is 0.05368 required upon given, which is 1 by 2 in that case. So this is equal to about 0.02684 moles. So 0.02684 moles. Now you can find the C from here. So C is equal to N times V, N divided by V. So N is 0.02684 moles. Divide this by the 0.05 liters of that. When you do the division, you will get 0.537 moles per liter. And this is your answer. Again, we use the derivative geometry in the solutions geometry. So again, the derivative geometry is the main thing you have to know and use in all these geometries. So that's how this works, and these are the easy type of questions. You have to just know about the formulas in this and what formulas you have to use in which geometry. Done. And then we're doing the geometry analysis, where we're doing the limiting reagent and the accessory reagent. That question is evolved that thing now. So we have to identify the limiting and the accessory agents and find the chemical amount of the accessory agent that will remain inactive when 2.20 moles of magnesium reacts with the 3.30 moles of hydrochloric acid. So what you have to do, so I will tell you. Done. So what you have to do, this is it's like not very like a same question we did in the ice tables. This is some slightly different. We don't use ice table in that question because this question is directly doing by the like just the calculation. We can't use the ice table any like more in this because we have to just know about the ice table for now. We're doing the proper ice table questions in the great value chemistry. For this, we have to first write the equation. So the magnesium it reacts with the hydrochloric acid. So which is Mg solid, it reacts with HCl aqueous, we will get an MgCl2. We have to balance this thing and we also release H2, I think. Yeah. H2 is the release in that reaction, which is in gas. Then we need just 2 over there. So now we have a moles given. So if we have a moles of 2.20 moles and we have moles for this. So the more of the work is done for us. We don't have like a mass, molar mass, that thing. We just have the moles. Now we have to divide this thing by the number of moles the magnesium has. Magnesium has only 1 mole and this has only 2 moles. So this divided by 2, you will get about 1.65 moles and this stays the same. So what's the sets reagent? This one. This one is the sets reagent and this one is your limiting reagent. Done. We identify that thing. Now we have to find the chemical amount for the SS reagent that will unreact it. So for this we have to just find this thing. But how? We have 2.20 originally and we have to minus this by the limiting reagent because that was used. So 1.65 moles of thing has been used because this is a limiting one. So how much we left with? Which is actually the chemical amount for the magnesium, which is 0.550 moles of that. So that's the main thing. And if you have to get the full mass, you have to show this all thing that how the chemical amount of SS reagent that will remain inert can be found from the limiting reagent and this SS reagent. You get the like just about like half, like you cut the mass. Like if you just find this thing, you have to find this thing if they ask about that thing. So you have to know that how this type of questions works in the ice table questions. So sometimes that they are more trickier, but you have to know, you have to do practice for this. So the next question we have over there from the yield question, we do the theoretical and the actual yield topic. From here we get this question. So question says in a chemical reaction done to test the stoichiometry method, 3.00 grams of silver nitrate in aqueous solution reacts with the large size of sodium chromate in solution to produce 2.81 gram of dry precipitate. So this was the key thing over there. What's the equation? So we have to find. So we'll determine the mass of the precipitate. Then we'll find the percent yield of that. Then so firstly we do with the mass of the precipitate. So what's the reaction? Is the silver nitrate in aqueous solution, which is AgNO3, which is the aqueous, and we have the sodium chromate, which is Na2CrO4, which is aqueous. This is double displacement, so we get Ag2CrO4 aqueous plus NaNO3, and this thing is also aqueous. Then no, this thing is solid. So this thing is solid, so we have to find the mass for this thing. You have to balance this whole, so this becomes 2 and this becomes also 2. So the molar mass for Ag2Cr2 is 331.74 grams per mole. You can see from your formula sheet. And you have to find the N first to find the mass. Then you do not have the enough information. You have the mass for EgNO3, which is 3.00 grams. You have the mass for this too, which is, wait, you don't have actually the mass for this, right? So if you think that this should be the mass of the precipitate, dry precipitate, so this is given for the actual thing. So this is 2.18 is the actual yield for that, which we use in the percent yield thing when we do this version. Then for now we have to find the thing which is the experimental. We'll find the experimental thing which is like near about that value. Done. So that's not the actual thing. This is the not the theoretical value. This is the actual value of that. Done. So to find the N for the Ag2CrO4, you have to find the agents first. So for this one, you can find the molar mass actually from here. So it's 169.87 grams per mole, which will become 0.0176 moles. Then you can multiply this by 2 moles to get your answer for this. For over there, you can find by the method called the stoichiometry. So 0.0176 moles, which is basically the 1 divided by 2. You will get 0.00883 moles. So this is the thing which is called the SS1. This will going to be the assess reagent. And when you find this, you will get this is the limiting reagent. And you can find the actually N from here now. So this should be over there 0.00883 moles, because you actually multiply this thing now. This thing goes over there and you are multiplying. So the mass is molar mass times the number of moles. So you get 2.93 grams. It's like near about 2.81, but this one is your experimental thing. Now, or you can say this is a predicted thing. So now you can actually do your formula in this, which you have to find the percent yield, which is the actual upon predicted. So actual, what's the actual? 2.81 grams divided by the 2.93 grams multiplied by 100. You will get about 95.9%. That much error you have, like percent yield you have. Then, so that's how this question was. I know this question is something tricky, but you don't get that much tricky question. I will choose that question because you have to know about that type of question. That sometimes you get that type of questions. You don't like that type of question. You get the simple questions in that. So you have to just know about the formula for the percent yield, for a percent difference, like the formula we did already in the lessons. So the last question we have for today. So this is from the titration thing. So we know we're doing the two topics for titration, and the first one topic where we're doing the all the thing which is involving the titration topic. In this involving the other topic will involve the curves, but their curves are like basically in the grade 12 chemistry, not for now. We're just doing the introduction thing. So that question we have. So the question says the student wants to find the concentration for the ammonia in the commercial solution and decides to do an analysis titrating the 10.00 ml samples of NH3 aqueous with a standardized solution of 1.48 moles per liter of HCl aqueous to produce ammonium chloride. Using evidence provided, determine the concentration of the ammonia solution. So write the equation first. Equation. So we have NH3 aqueous which react with the HCl aqueous, then which will become NH4Cl. Again, then so for NH3 we have the volume which is 10.00 ml, which is basically 0.01 liters. We have to find the concentration for the ammonia, but we don't have the N over there. So basically we have to find the N first from something else. So for the HCl, we have the concentration which is 1.48 moles per liter. And you can find the volume average of the HCl from this table. So basically, you know how to do this. So final minus initial and get the values in. So 15.0 minus 0.3, you get 14.7. 14.7. So 29.1 minus 15.0, you get 14.1. 43.0 minus 29.1 is 13.9. 14.4 minus 0.4 is 14.0. You have to cut one value, which is in that case is this thing, third one. So you can now plus the thing. So 14.7 plus 14.1 plus 14.0 and divided by 3, you will get about 14.3 ml, which is in liters is 0.0143 liters. You can find the N from here, which is C times V. You will get N about 0.021164 moles. And this reaction is already balanced. So this was the same for the NH3, 0.021164 moles. You can find the C from here, which is N divided by V. So you will get about 2.1164 moles per liters. which is basically, tree said this 2.07 moles per liter. So that's your answer. So that's how this works, and you have to know about this question because this question is very important. You get one question for sure in your examinations, in your units, in your quizzes. So you have to know this. Very important questions. And we do more about in this in grade 12. So with that, we end the grade 11 chemistry. We've done the 4 units. You have a 4 units in your curriculum, and we completed that 4 units finally. So the grade 11 chemistry is completed. So what's next? So what's next is the CAM 30, which is the grade 12 chemistry. We started that thing as soon as possible. I think in September mid or in October. So make sure you watch the lessons too. So for now, you can do the grade 11 chemistry if you have. So we will start the grade 12 chemistry by the October 2026. So with that, we also completed unit 2. Unit is completed. We've done all the topics and we also completed the course too. So now that all for you, and so that's all for this lesson. Let me know how to learn but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till this with Edu. Bye.